You're listening to the For Climate Tech series on the Forward Faster podcast, providing bite-sized insights for climate tech innovators.
Hey, and welcome to Forward Faster. I'm Chris Carpenter from the marketing team at NextCore and Venture for Climate Tech. With me today is Shiv, Bhakta, co-founder and business development at Active Surfaces, and Dr. Richard Swartout, the co-founder and CTO. Thanks for joining us today, guys. How's it going?
Thanks for having us. It's great to be here.
Thank you. Great to be here as well. It's going good.
For those who don't know, Active Surfaces is in cohort 3 of Venture for Climate Tech, and we are doing kind of a deep dive into each of these companies and trying to learn more about you guys. So first off, can you tell me about Active Surfaces and what you guys are all about?
Yeah, we'd love to. So as you know, we're Active Surfaces, and we're aiming to revolutionize the solar industry with our lightweight, flexible solar tech developed at MIT. And the problem in the world that we're super focused on solving is that the solar that we know that's being installed globally today wasn't really built for the built environment. So we have developed a new tech that's flexible, it's lightweight, and you can actually integrate it where you couldn't put solar before. And this can save on labor costs, it can save on structural costs, and it can actually mean that we can accelerate the deployment of solar, especially in places where you couldn't put solar before. That's the key winning. And we do that with our awesome tech that Richard developed.
Yeah, Richard, can you dive in a little bit, just how you got involved with that research? I feel like solar panels have made leaps and bounds over the past decade, and to see you're holding one and bending one is kind of mind-bending to me.
I mean, there's a long history of solar, right? Well before me. Most of the technologies we know today were actually developed for the space race. These technologies now are 70 years old, right? Haven't really changed at all. You can see photos from the Jimmy Carter days of them putting solar on the roof, and it's the exact same panel structure, mounting systems, all of that. Nothing's really changed. The only thing that's really changed in that time is cost, and obviously public awareness. So these things have probably been academically interesting just as long, and we've always kind of known throughout that time that we can do better from just an engineering standpoint. So I work, and I did my PhD on what we call generation 3 semiconductors. So organic, perovskite, quantum dot, all those things. And what these technologies in common is that they're easy to manufacture. So unlike silicon, where you have to grow this wafer, you have to dice it up, you have to tessellate it, and then eventually it gets onto your roof. You can print a lot of these things exactly like a newspaper. And again, also unlike silicon, these materials are very, very optimized for the application. A lot of these technologies don't need to be as big as silicon. So the actual active layer in many of these generation 3 things are 500 nanometers thick. And that's hard to put into perspective. That's 1/200th your human hair. So that's how we get the mechanical flexibility, because when you get down to something that thin, bending something no longer matters to the material really at all. Backing up how I got into this, Clean Tech 1.0 had just happened. So that was in my undergrad. And Clean Tech 1.0 was on kind of generation 2 technologies, and there was a lot of failures. But I got interested in the space, I got interested in the material science, and I came to MIT. And what we were doing at MIT when I first started was kind of novel approaches. So my first project ever was making sunglasses where the tinting of the sunglasses were actually a solar panel. So you could power applications there. But what quickly came out of all that stuff was the realization that manufacturing was still not optimized here, and nobody really knew how to do it. So I got to choose my PhD largely around manufacturing science to try to optimize and scale these things so that they were meaningful. We
have another program, Scale for Climate Tech, that deals a lot with manufacturing issues as well. So, it's not unique. It's crazy how much people just forgot about manufacturing and how ingrained it is into making tech work better.
Toward the end of my PhD, I was a part of a program, I consulted with a program called Start Nano. So we built a new manufacturing-esque facility when I was at MIT. And one of the statistics we throw around all the time is that it takes 20 years or so to build a new technology if you need to develop manufacturing. It takes about 10 years if you can leverage existing manufacturing. So the challenges are real if you have this technology that could be really interesting, but requires new ways of doing things. I think that's a lot of climate, to be honest. I think a lot of climate is about optimizing these newer technologies, and we need to start figuring out ways to do so.
So how'd you get connected and get to the point where you're at today?
During that journey that Richard mentioned, where he was developing those solar sunglasses, I was an undergrad in Houston, and then I went to a couple of different companies, ExxonMobil, and then the U.S. Department of Energy. So I was doing my own energy journey, seeing the traditional oil and gas sector, doing some project management at a refinery, and then going into the nuclear sector via NNSA, which is the subcomponent of the DOE, and then ending with OTT, which is their tech transfer office. So after having spent half a decade in energy, I figured it was time to go get an MBA / a Master's in Engineering, which is what I'm doing now at MIT. And in the first semester, I took this class called Climate Energy Ventures, where it's taught by partners from Breakthrough Energy and Seed to Growth Ventures, amongst others. And the goal is to incubate new climate tech startups. And they spin out a couple startups a year that end up getting venture backed, scaling pretty quickly. And we all enter in hoping to be that next moonshot. And it was nice because they pair people with different skills. There's people that come from the tech side, like Richard, people that come in from the business side, like myself, and there's policy and law and a few other perspectives. So you form multidimensional teams, you start developing a business plan, and that's how I ended up meeting Richard. And the very first networking event, we spent like an hour talking about the technology, and it was fun because I was a bit skeptical in the beginning, saying like, do we need this? Like, what is the actual market pull for this? And within an hour, I was like, okay, this guy knows what he's talking about. The tech seems validated. It just needs to scale. And I was pretty bought in.
A funny story I like hearing, I don't know if she's going to appreciate me telling this part of it, but he also came in with an idea and he ranked my technology over his own idea.
He knows a good idea when he sees one.
Exactly.
So my question for you is, what facet about this technology do you think is most exciting and allows for the biggest impact?
Yeah, I think, there's many different ways to describe it. I'll try to be as simple as possible. So I don't think we really appreciate just how much solar needs to scale, like at all. I think a lot of people today will look at the industry going on and they're like, oh, this is already a big economy. And the reality is we're like just at the beginning. We need by 2050 a minimum of 20 terawatts on the grid. We have 1 terawatt today. If you go through net zero scenarios or high electrification scenarios, some people estimate all the way up to like 70 terawatts. So we're at like the beginning 3% to 5% of penetration of solar onto the grid. I sometimes compare this to cell phones. We're at like the Nokia brick phone and we like need to get to the iPhone level of penetration. Our viewpoint is that you probably are not going to be able to do it with silicon alone. The amount of land you need is too high. The manufacturing capacity and supply chains for silicon and CadTel just will be difficult to justify that level. And there's a lot of emerging issues that have come up in the last 2 years, things like distribution of electricity, grid exchanges, even around the US, other densely populated areas. And so we see kind of like a solar 2.0 vision emerging in the future where, we have these utility scale things, which is pretty much what all solar is today. But then we have solar more ubiquitously integrated into our daily lives, into the built environment. And that's really where the benefits of a flexible technology come into play. If it's flexible, you can put it on facades, you can put it on roofs, you can put it on top of parking lots, you can put it next to roadways. I think the possibilities become more limitless when you change the form factor around. But at the end of the day, I think it's really needed for us to start thinking about these applications just because of how much solar we need.
So it sounds like you can put this product anywhere. When you think about the flexibility of this product, where do you see this being most used? Like in cities and towns and like kind of in devices, like it would be in my office or everywhere, or is it kind of like limitless?
Quickly, let me add some color on some of the comments Richard made, because he said the 1 terawatt to 20 terawatt or even 70 terawatts. And like a terawatt is such a large number that we struggle to understand that as humans, right? But to put it in perspective, it's equivalent to the largest solar farm that exists in the world today being deployed every day for the next 25 years. And that's just to hit 20 terawatts. So like at some point, we're going to run out of low-hanging fruit land to put this on. And we need to start integrating it into places where we couldn't put it before, which is why the ubiquitousness of solar that Richard mentioned is so important. And we're having conversations with regions where like we don't have that much free land. If you're living in Singapore, then like you need to integrate it into the built environment. If you're in New York City, then you can't generate enough power and build new transmission all over the place. There's time lags between some of this stuff. So being able to deploy solar in new places, I think is going to be critical to actually hit net zero goals. But where can we put it? We were just at a conference last week at NREL dedicated to putting PV everywhere. And this could be building integrated photovoltaics or vehicle integrated PV or space applications. And there's a lot of different unique use cases on where to put something. And our goal is to make any surface active. So you could theoretically put this anywhere, which is the dream when it's ubiquitous. But we have to get there, right? And to scale the manufacturing capacity, we've seen a lot of interesting short-term needs where you have a lot of value add in terms of the weight, in terms of the flexibility that are willing to take that chance on a new tech. And this could be disaster relief through things like FEMA, where you can easily roll out like a solar blanket after a hurricane or after an emergency and get power to a region. That's super important. There's DoD applications where you can lighten any soldier's load, or you can do this on remote sites, which is very attractive. And then there's even IoT applications like you mentioned. There's also unique application in the telecom space or remote city space where you have remote buildings that you can put this on. And you have to do less transport costs because solar panels are heavy and you have to transport this stuff long distances with glass, which is very fragile. But the larger market that's going to justify a gigawatt scale, we think, is going to be something as large as low load bearing commercial warehousing. And it sounds like a very niche market because we're specifically segmenting the warehousing market, but there's over $100 billion of opportunity here. And this is because a lot of buildings, especially in the US, are more than a decade old before solar PV was commonly installed. And even today, we're at less than 3% penetration to the market. So most buildings were not designed for this. And if you want to put solar on it, you have to reinforce that roof. That's expensive. So instead of doing that, what if you can unroll a yoga mat style solar panel and you can have a lot less weight with the same efficiency, way less cost, way less structural support, and you can make it more affordable for some of these warehouse owners to generate power on site. That's what we think is a multi-billion-dollar market.
Yeah, it's a total game changer. You've done your research, you've been working on the tech forever. I'm curious, like, what has been some of the obstacles with this?
I think like every month there's like some existential crisis that we have to work through. I mean, in very recent memory for us, I didn't expect how difficult it was going to be difficult may be the wrong word, how long it was going to take to fundraise. I mean, I knew this before going into this company, is that like there's been a lot of failure in energy generation just broadly, like solar is maybe the sticker boy to it. But when you're dealing with something as important as energy and as much of a commodity and pure commodity that energy actually is as well, it's like two very difficult things kind of put together. So energy generation just tends to be a difficult market to capitalize on. So a lot of investors just don't want to do it, period, right? So we knew that kind of going in. But even when we like had commitments, I didn't realize how long it was going to take. We are getting venture backed. So it's just, that was probably maybe the biggest realization for us starting out. Shiv, can you think of anything else?
There's two interesting ones that came to mind. I think it's because of all the customer discovery we've been doing this summer. One is about the education piece of it, this feeling that like, oh, solar panels exist in the world. And like, is it actually a problem in 5 years? And I think because we don't realize how much solar actually needs to be deployed, we think it's not as urgent of a problem as it actually is. And having to educate people on the actual trend of the solar industry, the actual trends of building stock and where we're actually deploying it, I think that piece of it for people that are less in tune with the market overall was super important to do that education. Something else was, I think, the market adoption strategy. Because I think right now, because it is being deployed globally, people view solar panels, even across technologies from CadTel to silicon, that's pretty interchangeable. And being able to innovate on that is going to require like a very specific go-to-market strategy. It won't just be as easy as going to an existing solar developer and getting a super large contract. We have to make sure that we take those stepping stones very deliberately to navigate that and get to a validated mass manufactured panel. And I think being able to understand what those stepping stones actually are, were pretty insightful this summer.
Nice. Congrats. I mean, that stuff's not easy to do. These next couple of questions are kind of directed at that too, is you both are clearly pretty brilliant guys. Why do you personally work in climate? You guys both have tons of different options in front of you between at MIT and stuff. And the startups are hard. So I'll hone the question even more so. Why do you work in the startup climate space?
I can take a first pass because this was my entire MBA application is like, what do you want to do post MBA? And people come in saying, I want to go work in consulting. I want to go work in investment banking. And like, I'm choosing to go take a less lucrative career path in the short term, just because I think it's something that matters in the world. So why climate and why startup? So on the climate side, I knew climate was my North Star when I came here. And I think I realized that when I left ExxonMobil. I think I realized that during my time at ExxonMobil, which is probably what led me to go to the DOE and then make my way here. But then like looking around at the different ways I can make a difference in the climate space, everyone is playing a super important role. So there is no role that are unimportant in this game. Like we need millions of people working on this. But I think the opportunity with active services and with a specific startup is super important, because you can actually be the voice of change and pioneer things in industry conferences. You can pioneer things with your partnerships with large organizations and move the needle. And you fully control not fully, but you have a lot of ability to scale something that's meaningful to the world. And being able to create something out of nothing is something that only you can do in the startup world. So I think that being able to do that and make your mark is nice.
Yeah, I mean, I'll start with why startup. I think that's the easiest for me. Is exactly what Shiv said. Nobody's going to adopt this technology unless a startup pushes it forward. And I'm like very passionate about it, very passionate about the manufacturing, the science challenges, the climate, but like I'm not going to be able to go and get like a corporate job somewhere and feel like I'm making a difference, because I'll just be, in a cubicle thinking about this stuff, and it's going to be business as usual for wherever I go. And so that's why I wanted to do a startup, because I really wanted to see the change that I wanted to develop come to reality. Climate, I did not actually apply to MIT specifically on climate. It was very interesting. For me, that's probably actually why I chose MIT. Climate today and climate tech is an intersection of broader problems I see with how we think and do engineering kind of in the deep tech space. Like it's a great nexus and platform in terms of developing kind of these harder technologies, because they're needed for our survival. Beyond what everything Shiv said in terms of like doing good for the world, which I also agree with, I also think it's going to change the landscape in terms of manufacturing science, tech transfer, all these things. I think being in the climate tech space will enable like a better future in terms of new technology development.
Thank you. And this is another one I always ask to folks towards the end of the interviews: what lesson or piece of advice from your founder journey would you share with another founder?
I like this question a lot, because I think it gets into my own personal journey getting to the founder. So active services actually got penned. This is a little nuance to the story. Got penned before I actually met Shiv. Right. So like I had filed Delaware C filings to start the company before I'd ever met Shiv. So I'd been thinking about it like for a while beforehand. And I think in that process of trying to create a company, trying to, establish the idea, especially as an individual person, it can get extremely stressful seeing the industry develop, like without you in it, all the different stakeholders who you talk to throughout that journey and who like are dismissive and things like that. And the best piece of advice I can give is wait for the right people who will support you. Active services has grown largely through people. So it's grown exponentially when I first met Shiv and realized that we paired ourselves and our journeys really, really well. Similarly, our first two employees with us, we took the time to get to know them, realized they overlap. They had the same sort of vision that we did, socially paired well, and obviously are very competent people. And 2 + 2 is way greater than 4. So for anyone thinking about spinning out a company, be patient, look for the right people to join you. And then once that match is made, you will move faster than everyone else around you.
Shiv, how about yourself?
Like Richard mentioned earlier, I think every month we face something that we feel existential, and it probably is for the company. And it's super stressful in the moment. And then there's a really stressful week and then a really less stressful week, and it ebbs and flows pretty dramatically. So I think the lesson that'd be interesting to share is that enjoy the ride, because it's going to be super stressful in like very key moments throughout the company continuously. And if you burn out, if you're stressed out all the time and you don't enjoy the ride, then you're not able to give it 100% and actually grow the company to where it's going to be. Because I think it's unavoidable. These key decisions that we have to make, it's all par for the course for a founder or an entrepreneur. But making sure that you're taking time for yourself, for your family is super important as well.
Awesome. And last question, we went from looking back to looking forward. Venture for Climate Tech, and you're the cohort 3 is, we're getting to the end of the curriculum stuff come the fall. What's Active Services plans after the cohort?
Continue growing. We're going to hire people. We're going to start getting lab access and further our tech development. Continue growing rapidly is the goal. Richard?
Yeah, like I said, we're closing financing. We're going to hire, get our first manufacturing off the ground, and our first partnerships off the ground. And I think Venture for Climate has done a really, really amazing job with supporting us so far, and we're happy to continue scaling. Yeah,
the mentors that we've gotten from Venture for Climate have been instrumental. The support from the community has been key, I think. We wouldn't be where we are today without it.
Well, shucks, guys. Thanks. Well, awesome. Thank you guys so much for stopping by, Richard and Shiv. So great to learn more about Active Services and all that you guys are up to, and excited to see what you guys do next. So thanks again, and tune in next time at Forward Faster.